Bismillahirrahmanirrahim. Welcome to Easy Learn, and this is the next episode that is recorded after a long time than the previous session. I recorded all the previous videos earlier, earlier in 2019, but now after a long gap due to my personal commitments and other study period and exam sessions and so on. So I was a little bit busy, so I prepare lectures again, starting again. So maybe you are continuously using the lectures, because all the lectures that was delivered according to the schedule on Easy Learn are pre-recorded, but now I had changed some of my quality. Also, quality is enhanced. Maybe you can understand if you are a previous user, but let's see what happens. But coming back to the point, what is the topic of the today's lecture? We are here to record on the introduction of sources of, for example, current source, voltage source, and the equivalent networks. Starting from the very basic thing, that is in the earlier videos, if you remember, that we discussed equivalent circuits. What are equivalent circuits? Actually, equivalent circuits are the circuits that are for example, this is our resistance and this is another resistance, and if these two resistors are connected in this way, we can replace this resistance with an equivalent resistance, which is the additive of these two values. We call that this is R1 and this is R2, let's suppose, and this is the equivalent in our circuit. Sometimes, for example, let's say this is for just the moment of understanding. This is our PCB. We call that this is our PCB, and we cannot add we want to add further features, like in smartphones. Just take an example. We have smartphones, and our phone is going to be slim and slimmer than in future. And the reduction of the size and networks is a main task. For example, just think that this is our PCB of a simple mobile phone, and this resistance is here, a resistance is here, a resistance here, and we want to add a new features. For example, we want to add a camera here, and for this purpose, we want to remove a resistance. We need to replace these three resistance with one resistance. Let's go for the sake of understanding. Then what we will do here, actually, we will just understand some techniques for the integrated circuits, and we will try to remove and replace this with such as like that, and there is the extra space, and easily choose the camera and its integrated circuits here. And this is the way, and actually the benefit. Number one, it is easier for the analysis and understanding equivalent circuits, but for the first time it is very difficult task, because the circuits are going to be complex, but it is very useful technique to reduce the size. It reduces the cost. The three components can be replaced with one component. This is a simple understanding of the equivalent circuits, and we already discussed this in our previous lectures in this course. But coming back to the point, we are now going to discuss this with our active sources. What is active sources? Active sources, are the sources that are voltage or current source. So what is the voltage and current source? Voltage and current source, there are different types of source. For example, this is a voltage source. You just add positive, negative here, while there is another way to represent this with the circle, positive, negative. This is also voltage source. Same is the case with the current. Different types of representation of the voltage source. This is a constant voltage source, while this is a time depending varying voltage source. For example, it can be like this type of waveform, while it is a constant waveform that is not changing its polarity with respect to time, but it's going to be constant. So different types of voltage source and current sources, but main our focus is active sources. It doesn't matter which type of source, it is further categories. There are, you know, hundred of categories can be derived. We are going into details, but right now we are coming to the discussion that this is, for example, voltage source, and I am just choosing here a simple voltage source. Like this is a time varying voltage source, and if we have here another voltage source, and that two sources are connected in series. So this is a series circuit. I am just writing here S. S means this is a series circuit, and in series circuit your voltage is not constant. Your current remains constant, because you know, the current has only one path to flow, while in a parallel circuit current splits up. Current have multiple paths. But let's take a look, and for a better understanding we just write at the one corner of the page that in series circuit what is the concept. As I said that in series circuit your current doesn't change. I'm just writing here I same, while the voltage varies. So in parallel circuit your current it changes, it is just reversed. Your current varies but your voltage is constant. I've just tick mark on for the better understanding, just my shortcuts actually. Okay, this is the first, that is our V1, that is our V2, just for the understanding, and different representation to call them, and this is connected with the rest of the network. One thing more I want to tell you here, that if I just add 2 points here, like I added here 2 marks, you can see, then I mean actually the next coming point is the rest of the network, and I am not linked and associated with the rest of network. This means that it is now ready and it can be connected with the rest of network, but not right now. We are not interested in. If I just add the 2 points in the bold section, 2 circles, you can see the next time you are understood that this is the rest of network. This means that this portion belongs to rest of network, and we are interested in studying this. So okay, right now if we focus on the main point, that is this right now, 2 voltage source that are connected in series. It means the 2 voltage source, if are connected in series, their voltage will be definitely changing. If it has a different volt, for example, it is having a 4 volts and it has 3 volts, so the total equivalent sources will be varied. What is a simple understanding for this is your cells of the remote control devices. You can easily see if you open the TV remote, I know you open many times, there are the 2 cells. For example, this is your first Duracell. Just for the understanding, I just mentioned the Duracells. And this is your second cell, and if we connect this cell with this cell on the lower side, and you have just read it, this is 1.5 and this is 1.5, and both cells after combination, you know, first it is the negative terminal, it is the positive terminal. Okay, so 1.5 volts coming here, and after passing to this side, this 1.5 are further added in this 1.5 series to make it 3 volts at the end of the terminal. After passing this cell, 1.5 volt push is added. So it means that in a series circuit, when the voltage are following throughout the sequence, if the sources are added, they are all going to push this circuit. So we can simply say that the equivalent circuit of this type of network is simple. Just add one simple circuit, which is the sum of V1, V2. If there are 3 voltage sources that are connected, then you can add just 1, 2, 3. I mean, here if we understand the example, like here 3 volts plus 4 volts. So it means that here in our case V is equals to 3 volts plus 4 volts is equals to 7 volts. So this must be 7 volts to equivalent. So we can call it that it is the equivalent source. This is the case for the voltage case, and now let us discuss the current case. Say it is, current case is definitely the reverse, because both are reverse of each other. But now we discussed the series combination. Now let us discuss the parallel combination. In parallel combination, so here you can see two current sources that are connected in parallel. In parallel combination, if this is current I1, just to call these two different sources, you can see the first current is coming here, and then the current is here, and then the current is going here. If current can go in this direction, if the other current source I2, because this is a parallel combination source, remember that in parallel combination source your voltage will not be going to change, but current will be added up if there are the two current source. So if it can come in this direction, but here is another source, so it provides another push. So two currents pushes here, and then the next current that emerges out from this node is the sum of this current plus this current. So the output terminal of this current will be the sum of these two currents. That is the definitely double or bold current. As you can see, my arrow is bolded up after coming to this point. So this will not gonna be happen. This will not gonna be happen wrong direction until the I2 is an active source. So we can simply say the equivalent source of this network is, if it is connected in parallel, I is equals to I1 plus I2. Like here, if for the sake of understanding this example case, this is 4 ampere and this is 3 ampere, and 4 plus 3 simple 7 ampere source. If you connect here, then it can be simple the replaceable term. Remember that we cannot connect the opposite strategies. Like here we mentioned that you can see here what we choose here, we connect the two voltage source in series. Then what is the benefit of this connecting the two voltage source in series? The overall voltage is added up, like in the case of the remote. But if we are ready to connect the voltage in parallel, like if we choose the opposite to this scenario, let's suppose I want to add, I am doing something like this is a voltage source, this is a voltage source, and I am ready to connect them in another way in parallel. So what does happen? The voltage that is coming from here, this side, it wanted to go through this way. I mean, if for 5, for example, this is a 5 volt, here we have the 5 volts that is coming out here overall, the 5 volts. Till here we having 5 volts. Before reaching this node, we have 5 volts across this. If this source is also 5 volts, it have no impact overall, because in parallel the voltage remains the same. So across this, if it is balanced, it will go on. So overall we can simply say if the two voltage source are same, then we can simply say its equivalent circuit can be only one source that is 5 volts, not the sum. I mean not 5 plus 5 10, because this is a parallel combination, and in parallel combination, as I mentioned, the voltage doesn't add up, voltage remains the same. So But remember that you must not connect the voltage source in parallel, until they are not the same potential. For example, if it is uh, having 3 volts, it is having 5 volts, then what happens? The voltage of this area is little bit lower than this one. So voltage will trying to balance this one and this one branch. These two branches voltage try to balance, because in parallel voltage remains a same voltage. There must be same voltage in two branches. So what happens? Actually, this is the higher potential. Higher potential tries to contact with this one, and its potential is raised to some extent. So overall, the potential is reduced, and we will not try to select this one. This battery will be acting as an active element, while this is using some of its potential. So this temperature of this battery may be going to rise, and its life is decreased. So we cannot choose like these type of options. Remember that whenever you wanted to gain more voltages, wanted a circuit of 3 volts, and we have 1.5 volt battery, then what we did? We connected the cells in series. So this is a simple example, always in your mind to understand. So same is the case as I mentioned here. If this is a case of this is the case of the voltage. Now let us discuss the case of the current. What is the case of the current? I said that if we connect the current sources in parallel, their equivalent source will be the additive of the two. The overall current is added up. But if we wanted to connect the two current sources in series, I mean again opposite as in the case of the current, same I wanted to do with the current sources, then what is the equivalent source? So this is the rest of the network. We are not interested in the rest of the network. What is the, again, we are only connecting the current source in this way until they are same. Okay, current sources must be same, but this way gonna be the wrong way if they are not same. This is wrong. So why again I said that the higher potential will behave as an active element, while the other will be behaving as a passive element. For example, this is our 3 ampere source, and this must also be 3 ampere. In order we have here getting overall, I don't know about the voltage, but we are interested in the current. Sorry, we have the current overall same 3 ampere, because it in series, both the current that is coming, we have to pass through this point and pass through this point. So current must have to be the same. If the current is reduced here, for example 2 ampere, then what happens? 2 ampere current is coming, and when the higher current, it tries to balance this portion. So the overall its balanced portion will be definitely 3 and 2. The average will be definitely 2.5 ampere overall current you are receiving here for the rest of the network. So trying to choose the right options always. So this is actually the game of the series and the parallel combination. Current sources cannot be connected in series unless identical sources. Always remember. Okay, coming towards the next example, if we are having here 5 volt source, simple, just for the understanding, 5 volt source, suppose, and we have simple a resistive network here, simple resistive network, and let's suppose this is R1, and here the rest of the network, we are not interested here for the rest of the network. The voltage that here you can see that these two R1, that is R1 is connected in parallel with the voltage source. In a parallel combination, the voltage remains the same. First of all, voltage is same. So what is same? Voltage across R1 is 5 volts, because here if it is 5 volts, that 5 volts, 5, 5, 5, 5, 5 here, and then 5 volts which is here. Okay. Next point is to check the current, because we are discussing the today equivalent sources. So we are ready to discuss about the equivalent source of this network. For discussion of the equivalent source, we have to understand first the basics. So what is the current across this? For getting about the current, we need to apply the formula. What formula? First understand what type of circuit is this. This is a resistive element. Okay, you can see this is simple resistive circuit. If it was a capacitor, we will definitely choose the right formula for the capacitor from the table that we earlier introduced in some episodes. I don't know the exact number of episodes, but in earlier episodes in chapter number 1. So from him at this point, I is equals to V over R. This is a formula for the current. So applying this formula, what is the voltage here? You can see voltage is 5 volts. So what is the value of the current? If we say, resistor, for example, this is a 2 ohm resistor, just use here 2, and the overall 2 and this 2 after cutting, this will be 2.5 amp. So we can say that the current is calculated by applying the formula and it only depends upon this voltage source. So the equivalent circuit will be simple, very simple. That is very simple. This is equivalent circuit and it has no impact. For the rest of the network, we are only considering this. For example, 5 volts. For the rest of the network, for example, here we have another resistance, here we have inductor, here we have another inductor, here we have another inductor, here we have a capacitor. For the rest of the network, we are just taking it for 5 volts. Even we can sometimes neglect even sometimes because in a series parallel combination circuit, it always have the same voltages. The voltage we here is the source voltage, so it only depends upon the source. If so, we have no impact here. Overall, the voltage across this point is the same as the source. So let us discuss now the case of the current. As we discussed here, the and special case for the resistor, same is the case for the, like here we have a current source and we have connected here. You can see in the earlier example I gave you the resistance with voltage but in parallel. Right now we have a resistance in series, because in current network, when we are discussing the properties of the current, they are totally different with respect to the voltage analysis. So this is R1 and this is our I, any current, and this is from here we have a rest of network. So what is the formula, what is the discussion for the what is the rules actually in series? In series circuit, what happens, the voltage voltage varies, but the current always remains the same. Voltage varies. So voltage if varies, we have to worry about the voltage, because the current is same. Current have to flow through this way, to this way. I mean, current has only one way to flow. There are no other ways to flow. Current is coming and has to pass through the resistance and then reaches here. So there is only one way. So overall, we can say that we have to only worry. Current is the same. Like here, if we have 3 ampere, current across R1 will be 3 ampere. So voltage again, V is equals to IR formula. V is equals to current is 3, resistance is 2, again 2 ohm, 3 into 2, 6 volts. So across this we can say we have 6 volts. So this is a way we can calculate the voltage and resistance across a resistor and we can also find out the equivalent circuit. For what is the equivalent circuit for this? As you can see, a resistor is connected with a current source in series, but this has no impact in overall current. We are actually getting here 3 ampere current. We have no impact, so we can neglect a series resistance with a current source. I mean, we have so this is the equivalent source for a current for resistance connected in a current. So I mean, if we have a resistance here, we can simply neglect it. So the rest of the network has no impact on it. So this is the end of the today's lecture. I will try to reduce the timeline because the quality is enhanced, and by the enhance of the quality, I had also decided to reduce the timing of a lecture, so all the students can easily watch and manage, and I can also easily watch and manage, because it is difficult for me to deliver in a single lecture so many topics and so much data. So hopefully you got this little bit understanding. In the next video, I will try to introduce some of a little bit complex circuit and its analysis in the formulas form. With the help of the formula, we try to understand this concept again. So inshallah, we will meet in the coming lecture. Take care. Allah Hafiz.